Hello there, everybody. Root Beer here, and I'm going to be starting another of the University of Waterloo math contests. I'll be doing another Euclid contest. So this is the big, important paper. It's sometimes called the scholarship paper because if you do well on it, it's a good thing to put on university transcripts. It can get you scholarships. So we'll be going through the 2010 Euclid paper. As usual, you can get a copy by clicking the very first link in the description. So I encourage you to do that and try the contest out for yourself. We'll just take a very brief look, as I try and do at the start, just in case you're unfamiliar with the contest. It's 2.5 hours. You are allowed calculators. Looks like non-programmable this year. But I think in more recent years they've been allowing programmable calculators, provided the RAM has been erased. But I would look into that for your current year before you just decide to bring a graphing calculator and have it taken away. So there's a couple types of questions. There's short answer, where if you get the right answer and put it in the box they provide, you get all the marks. If you don't get that right, people who are marking look for part marks. And then there's full solutions, where you have to explain things. You know, if you're going to use the Pythagorean theorem, say, by the Pythagorean theorem we know, blah, blah. And you got to basically justify the right parts of the solution. Okay, so you're welcome to read through this whole thing here. I'm just going to, as I usually do, go through one question per video. So we'll start off with question number 1. It's got 2 light bulbs and a written. This is sort of standard. You'll often find question number 1 has 3 parts to it, 2 light bulbs and a very basic written question. So what have we got for 1A? If 3 to the x equals 27, what is the value of 3 to the x plus 2? Now, depending on how quickly you're able to work these things out, you might already know that 3 to the 3 is 27. In which case, well, you know what x is. X is going to be 3. And you can work out from there that 3 to the x plus 2 is 3 to the 5, and that's 243. You might need your calculator for that. But another way to go about it is you don't actually need to figure out what x is. Because when you have a sum in your exponents, that turns into a product of 2 different exponents with the same base. And I know what 3 to the x is. It's 27. I know what 3 to the 2 is. It's 9. 27 times 9. Again, if you need to, grab your calculator, and you'll get 243. And you would put that in the box provided in the answer booklet. Okay, very straightforward. How about 1b? So we've got some more powers here. If 2 to the 5 times 3 to the 13 times 5 to the 9 times x is the same as 2 to the 7, 3 to the 13, or 3 to the 14 times 5 to the 9, what is the value of x? Okay, so the nice thing here is each of these bases is a prime, so we've got 2, 3, and 5, so 3 to the 13, 5 to the 9, and then we've got x here, and that was 2 to the, I think it was 7, 3 to the 14, and 5 to the, what was it? 5 to the 9. Okay. So you can just say, well, x is going to look like 2 to the something, 3 to the something, and 5 to the something, and figure out what those somethings are because they're going to have to add. Or you could just divide both sides by 2 to the 5. And divide both sides by 3 to the 13, divide both sides by 5 to the 9. And remember, for the light bulb questions, you don't have to show your work. If you can just sort of do it in your head, that's fine. I'm pairing things up that have the same base so that I can very easily cancel out, because when you divide the same base, the exponents subtract. So 7 minus 5 is a 2. 14 minus 13 would give us 3 to the 1. And 9 minus 9 is 0, so that's 5 to the 0. So that's 2 squared, 4 times 3 times 5 to the 0 is 1. X has got to be 12, and that's what I would put in. Okay, and now C part, triangle ABC is enclosed by the lines x plus 2, y equals x plus 2, and y equals negative 1/2 x plus 2, and the x-axis. Okay, so this part. Okay, determine the area of triangle ABC. Okay, how do we find areas? Excuse me. How do we find areas of triangles? Well, there's a couple formulas, but the old standard is base times height. And if we take a look at the picture, and if we even bother to draw a picture of our own, we notice that point B, quite nicely up on the y-axis there, we can figure out how far up B is from the origin. We'll have a nice little altitude there. Okay, so the equations were y equals x plus 2. So we pass through the y-axis at 2. The other one, just to make sure that that is the intersection point, is negative 1/2 x plus 2. So B is at 0, 2, and that means we get a height of 2. So I've got the height, I just need the base. Well, how am I going to find the base? I need to find this point over here and this point over here. Well, these are the x-intercepts. They're the points on the x-axis that our lines intersect. And so they can be found by setting y equal to 0. So for our first equation, that is this point over here, 0 equals x plus 2. What's the x-coordinate got to be? And you'll get x is negative 2 here. Okay. Just going to write a little bit. Just because it's a written question, I should probably write a bit more. B is y-intercept. BO is a height or altitude, and it's of length 2. AC is the base. A is at negative 2, 0, since it's the x-intercept of y equals x plus 2. And C, I do have the order of these guys, right? Yeah, it was A first. Okay. C is at, all right, what's the intercept for this line over here? Well, we'll have 0 is negative 1/2 x plus 2. Bring the 2 over to the other side. That's negative 2 is negative 1/2 x. And so that's going to be, x is going to be 4. Get rid of the other sign. So x is at 4, 0. And so now, well, I need to move on to the next page. I've crammed enough in here. But I can figure out the distance AC is from negative 2, 0 to 4, 0. So AC is 6. And the area, which is what they want, is 1/2 base times height. Area of our triangle is 6. All right, so that squares away question number 1 quite nicely. I did make a point of showing a bit more work in my explanation when I did the written question here, 1C, indicated by the writing hand. And that's something you should be doing. You should be justifying where do these lengths come from, how do I do this calculation, what formula am I using, that sort of stuff. And we'll see many more written questions later on. Up next is going to be question number 2, and I do hope you take my advice, get a copy of this contest by clicking the first link in the description and trying question 2 on your own, question 3 on your own, before just coming back and watching my videos or just reading the solutions online. It is so much better in terms of the value of practice versus the value of sort of watching or spectating. Okay? But I will see you in the next video for question number 2. Take care.